All right, so if you're asked to graph a quadratic without graphing technology, you have a couple of different options. The first one would be to just do a table of values, like any line or graph at all. You could do a table of values like x, y, right? And then just plug in some values, and then you might get a sense of where the parabola is. You could do that. I would suggest maybe looking at a few other things to help you with graphing. So I would do some table of values questions, but first I would notice that this constant is 8, and so that means that if we were to graph this, that y equals 8, so let's say it's up here, that there's going to be a point on this parabola that is 8. We know that, 0, 8. Okay, that's a constant. Now, it's going to open upward, you see, because we have a positive here, and also the a value is 1. So do you guys remember, I think I told you this last class, that if a is 1, that means that okay, we don't know the vertex. So if we find the vertex, two other points can be derived really easily. So if this is the vertex, and we don't know it yet, but you could go over 1 unit and then up or down a units. So then you move from there, you would go a units to get the next point. So that's just a little aside. When we get there, we might want to be able to add 2 more points that way. But we don't know what the vertex is because this is not in vertex form. And right now, in this course, I haven't taught you how to change this into vertex form. If this is a perfect square trinomial, you can write it in vertex form. But if it's not, you don't know how to do that yet. It's called completing the square. If you want to look at some of my other videos on completing the square in pre-calculus 20, maybe pre-calculus 30, you can. But you don't have to know how to do that. So what I would suggest is this. Let's try to factor. Now, can we factor this? This looks like it may be factorable. I got to get to positive 8, right, in my multiplication, and I got to add to negative 6. So I'm thinking negative 4 and negative 2 would be my magic numbers there. You guys see that? So does that multiply? Yeah, let's see. Positive 8, yeah. Add these up, negative 6. So that's my factored form. Now that's really important because at positive 4 and positive 2 are my roots. So 2 and 4. Look at this. Those are 2 points right there. Okay. So are you with me on that? The factoring and seeing that those are x-intercepts? Okay. Now why are those x-intercepts? Because if I let this side equal 0, I use the zero product principle, and whatever x value makes this 0 is a root. Whatever makes this 0 is a root. So that's how you know. Okay. Okay. The picture is looking pretty good right now. There's one more thing I can find, and that would be the vertex. So like, how low do I have to go here? Well, x equals 3 is my x value for the vertex. That's the axis of symmetry. You see that? So there's a few things I could do. I could find the vertex now, and I'm going to just plug 3 into x to solve for y. So that's 3 squared minus 6 times 3 plus 8. That's going to give me my partner y value for my vertex. So 9 minus 18 plus 8, that's negative 9 plus 8, that's negative 1, I think. Looks like. So 9 plus 8 is 17, minus 18 is negative 1. So here's my vertex. Okay. 3, negative 1 is my vertex. This is not a good scale here, but that's my vertex. Okay. So I've got now 4 points. I can draw a really nice parabola. One more point that you could do is, you know that this, because this axis of symmetry literally means that any point on the parabola is the exact same distance from the axis of symmetry to another point on the parabola that's on a horizontal line. So if this is, I know now that this is 3 units from the axis of symmetry. So guess what? 3 units this way, I'll have another point that's on the parabola because it has to be symmetrical with this one. You see? So now I've got 5 points. This is great. You can draw a really nice parabola, and I'll do my best here to kind of try and draw this, but oh boy, that's terrible. This tablet is really tough to draw freehand with. Okay, so here we go, and I'm going to go here, and my 1 is definitely not to scale, so I'm going to fix that in a second. But that would be your parabola right there, and actually, if that's 8, this is closer to negative 1, so I'm going to adjust that, and that's perfect. Okay, so that's a way you can graph a parabola using the constant as the y-intercept, using the factored form for the roots, The halfway point between the roots would be the axis of symmetry. Use that to find the vertex. Use symmetry to plot some other points, and you're good. Okay? Now let's go back to that A thing. This is what I'll finish off with. Remember the A equals 1? So that means that if I go from the vertex, if I go over 1 unit and up 1 unit, I should hit a point on the parabola, and that's exactly what happens. You see? We over 1, up 1. That is the root here, and that's on the parabola. So everything is lining up. That answer your question? Yeah? Does anybody else have any questions about this? So did we use table of values? Actually, no, we didn't need to, but I could have done this. 1, I put a 1 in there, and that's 1 minus 6 is negative 5 plus 8 is 3. So 1, 3, that should be on the parabola too. There we go. And then I know that there's another one that's symmetrical over here. That's another point, and so on. So you could use your table of values too.
That was easy.
Okay, no other questions? What else do I have? I have a bell too.
Oh, do it again.
Orders up! Does that bother you, the ding?
Yeah.
Really? I didn't know that. I'll do that more often now. I didn't know it bothers you. Okay. Yeah, every time I catch you talking, that bell's going to be ringing all day. Let's be honest. Okay, we done? I'm done.
That was easy.
Oh, cringe. Love it.